Hello, I'm Teacher Jess and welcome back to Geo Cafe. How you guys doing? Okay, so I hope you guys have your coffee cups ready. I got this lovely new one given to me as a gift from one of the teachers, so thank you very much. The content for this particular video is map work. It's a topic that I think a lot of my students struggle with, and that is bearings and magnetic declination. I know that a lot of people do struggle with this, so don't stress if you don't get it immediately. That's why I do it year after year. Hopefully, once the penny drops, once it makes sense, it'll come so easily. So our topic for today is bearings. So there's two different types of bearings. We're going to take a look at that, and magnetic declination. All of this relates to interpreting directions on a map. So a lot of us are comfortable with the very normal north, east, south, west. We can do those types of compass directions and general directions. But when you want to be a little bit more um, accurate, precise, when you want to be a little bit more precise, you would use bearings. And we have two different types of bearing. The one is true bearing and the other is magnetic bearing. They are both a clockwise measurement. So you'll notice I've got the two definitions underneath each other. Both of them are an angle. They're both measured in a clockwise direction, and they're both measured from north. But this is where I'm going to drop a bit of a geography bombshell. There are different types of north. There's true north, which is what you would read on the top of a map. And then there's magnetic north, the way that a compass would point. So there we go. This is a nice little diagram of what the Earth's magnetic field looks like. And you can see over here, this is supposed to be the magnetic North Pole, but then this is the North Pole on the maps. So you can see that the true north, as in on the map, is not the same as magnetic north. So that's why we have two different versions of bearing. The one is where you measure from true north, that is true bearing, and the other is from magnetic north, so that is magnetic bearing. Let's start with how to find true bearing. So this is a very straightforward set of instructions. First, you need to find your points of interest. So I want to know the bearing of my finish point from my start point. So when it comes to finding true bearings, we always just start at the start point. So you find your start point, you read the question carefully. What is the bearing of this from this? So look at where you're starting. When you have that spot, draw a north-south line through that starting point. Okay, that's step number one. Great, well done. Okay, step number two, connect the dots. So now you draw another line from your start to your finish point. Okay, so far, so good, hopefully. Now, I specifically took this map because it's not as straightforward to measure as if the finish was like on this side, for example. So I'm going to start by using a 360 protractor. So this one is one of those round ones that goes all the way around. I always recommend students do, if they can get hold of these, use it. I know that most students have those 180-degree protractors. I'll show you how to use that one as well. Okay, now what we do is you take the center point of the protractor, you put it onto the start point, and then you make sure that this is in line with the zero. Can you see the zero over there? Hopefully. Okay, so you make sure that's in line with the zero. And now we read clockwise. So I'm going to start there. I'm going to read clockwise all the way around. And I don't know if you guys can see these values very clearly, but it's kind of between 17 and 18. So it's 318. You got a little bit of leeway. There's always a little margin of error. And this is in degrees. So we have 318 degrees. That is our true bearing. Now let's say that you only have one of these protractors, one of the 180 ones. What you do is you first measure your starting 180 and then you turn it around. Now notice where the 0 is. You see I've put the 0 at the bottom. Let me go back. You see there the 0 was at the top. Oopsie, I went too far back. And now I turned it that the 0 is at the bottom. And I'm going to measure the rest from that 0 all the way up. That looks like 137, 38. What did I record? 138. Okay. Now you take your first 180 that you measured at the beginning. You add it to the second little piece over here, and you get the same 318. Now it's going to get a little bit more complicated when we look at magnetic bearing. Hello. There we go. So we said that magnetic north. Yes. Sorry, my words failed me over there. Magnetic north is not in the same line as true north. And magnetic declination tells us how much it's off by. So what is the difference in degrees between true north and magnetic north? That's what magnetic declination is. We use that to find magnetic north. Let's first look at how to work out magnetic declination. This is another question that I see come up very often in exams, so it's good to have this technique down. Okay, on the bottom of a map or at some part of a map, you will see these two little arrows. So that one goes to true north and that one points to magnetic north. And you will see it has a magnetic declination usually already, which is fantastic, except this is outdated. You can see that this was printed in 2001. It's now 2024. And this magnetic north moves a little bit every year. But they tell you over here that the annual change is 4 minutes west. So what that means is that it moves a little bit more west every year. So hopefully you can already see where this is going to go. If I want to know what is this year's magnetic declination, I need to work out how many times it moved by 4 minutes to the west. Okay. If that's overwhelming for now, don't worry. I have it in a step-by-step. So this is a little step-by-step that I've put together for my students. It's the 5 steps of finding magnetic declination. You can always assume that the map that you're given is going to be slightly outdated. So you can always assume that it's either from last year or a few years back, or sometimes they even ask you an interesting one, like what will it be in 5 years' time or something like that. Okay, so step number 1, I need to know what was my old declination in my starting or my old year. So the old year in this one was 2001. And the magnetic declination in that year, there we can see, is 17 degrees and 45 minutes. So I'm going to write that down so long. Okay, so the declination for my old year was 17 degrees and 45 minutes. But I'm going to add in one little more detail. You need to remember to add west. Notice that it's going towards the west. That is important. Okay. It's moving 4 minutes every year to the west. It's important. Okay, so annual change, 4 minutes to the west every year. How many years has it changed? So I take the new year, 2024, minus the old year, and it's changed for 23 years. So how much should it change altogether? 4 times 23. And I just did a little number crunching, and you get 92 minutes. Okay, now I don't know if you guys remember this. I did this in a previous video, but there are 60 minutes in a degree. So if I see over here 92 minutes, I know that it's at least a degree. So it's 1 degree and 32 minutes. If you're not sure about that one, we can always go back to coordinates at a later stage. So the total change, it moved 1 degree and 32 minutes to the west. Now I put it into the formula. I take my old declination, I add the change, and then I can get the new declination. So I have 17 degrees and 45 minutes plus 1 degree and 32 minutes. So for starters, I just added the 17 and the 1, and I got 18. And then I added the 45 and the 32, and I got 77. Now, hopefully, again, you will see this as a little red flag and say that's more than 60. Yes, it's more than 60, so it's another whole degree. 19 degrees and 17 minutes. Okay, if you noticed, you may have seen that we have a plus and minus over here. So the new declination is the old one plus or minus the change. And you might wonder, how do you know when you're supposed to plus or when you're supposed to minus? And it's quite simple. As some teachers, they say if it's in the one direction, it must always be plus. If the other direction, always be minus. Don't think about it like that. Think about it as getting bigger or getting smaller. We know that the declination is already to the west, right? And it's moving more to the west. So if it's west and it's moving more west, you're making it bigger. You're adding it. Let's say the declination was to the east and it's moving every year towards the east. It's becoming more east, so you're adding it. If the declination was to the west, but every year it was moving to the east, now you can see it's going in the opposite direction. That's when you subtract. When it's moving against each other, then you subtract. Okay, now let's see how this all comes together. Magnetic bearing, I told you, was the measure from magnetic north. We take our true north that we measured right at the beginning. We add what we worked out. We add how much it was off by. And then those two pieces together will give us the whole angle. We take the 318, that's what we measured right at the beginning. We added the declination that we just worked out, and my magnetic bearing is now 337 degrees and 17 minutes. I hope this is making sense, and I hope that this was helpful. Have a lovely day. I hope to see you guys again soon and be good. Cheers. Bye.